Good day viewers, I am Rica Jane V. Navarro of STEM 11 YA6P of Our Lady of Fatima. Today's topic is all about standard normal distribution, and I will be teaching you how to determine an area or probability using the z-table. Standard normal distribution is where the mean is always equal to 0 and has intervals that increase by 1. Where each number on the horizontal axis corresponds to a set score. Now what is z-scores? It is a measure of position that tells us the number of standard deviation of value is from the mean. Keep in mind that the z-score is positive if the value lies above the mean and negative if it lies below the mean. These z-scores are very important because it makes it much easier for us to calculate areas, which are probabilities. We can find out that exact area using the z-score table. This table tells us the total amount of an area contained to the left side of any value z. The top row and the first column of this table corresponds to set values and all the numbers in the middle correspond to areas. So basically, we are using the z-table to determine the area because it tells us the exact amount of area of the z-scores. So we're just simply looking at the top row and the first column of the z-table. And in the middle of that is the area we are looking for. For us to further understand, let us proceed to the examples. Let us determine the area under the normal curve of the following z-scores. Example number 1. Let us determine the area from z-score 1.32. I shaded z-score 1.32 and using the z-table, we will now know the area of the shaded region. At the first column, we will find 1.3. And from the top row, we will find 0.2. And there we have an area of 0.4066. So that is a very simple example. Now let us proceed to example number 2. For example number 2, we will determine the area to the right of negative 2.5. If we look for the area of negative 2.5, it is equal to 0.4938. And since to the right of the z-score negative 2.5, we will add half of an area of the normal curve 0.5000 or simply 0.5. And we get an area of 0.9938. For the third example, we will determine the area to the left of 1.5. If we look for the area of 1.5, it is equal to 0.4332. And since to the left of z-score 1.5, we will add half of an area of the normal curve 0.5000 or simply 0.5 and we get an area of 0.9332. For the last example, we will determine the area between z-score negative 1.5 to z-score 2.5. Since the area of 1.5 is 0.4332, we will just add this to the area of 2.5, which is 0.4938. And we will get an area of 0.927. Now that I already teach you to calculate the areas, it is now your turn to answer on your own. I will give you 10 seconds to pause this video and we will proceed in answering the following examples. So my first example is to determine the area to the right of 1.45. Since the area of the z-score 1.45 is 0.4265, if we take a look at the z-table, we will now simply add the half of the area of the normal curve to the area of 1.45. So here we'll have 0.5000 or simply 0.5 plus 0.4265 It is now equal to 0.9265. I hope you get that right. For the second example, we will determine the area to the left of negative 2.35. If we take a look at the z table, we will now know that its area is 0.4906. Since to the left of z-score negative 2.35, we will simply add half of the normal curve area to its area, which is 0.4906. And in total of that, we will get 0.9906. I hope you also get that right. Now let us proceed to the last example. For the last example, we will determine the area between z-score negative 2.5 and z-score 2.5. If we take a look at the z table, we will also know that the area for negative 2.5 is equal to 0.4938. And the area for 2.5 is equal to 0.4932. We will now simply add the two areas to determine the area between them. If we get the sum of the two areas, we will get 0.9876. So that is the last example, and I hope you get all of them right. We are all done. For further understanding, feel free to look back on this video. Thank you for watching, and I hope you have learned how to determine the areas with me. Let us not forget what James Joseph Sylvester said, that mathematics is the music of reason. Bye-bye!